Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh to all students. So now let's go through the new chapter. There is semiconductor materials. So the previous chapter that you have learned is op-amp and equivalent circuit of the amplifier. So now let's go to the chemistry. There is semiconductor material. Okay, what you're going to learn in this chapter is the classification of the materials. So we have three material: insulator, conductor, and semiconductor. And what is actually semiconductor materials, and what is the difference between intrinsic, extrinsic, and in the semiconductor for the extrinsic we have N-type and we have P-type. And what is the difference between band gap energy for the conductor, insulator, and semiconductor, and the last one is the Fermi level. So this is all the chemistry part for the semiconductor material. Okay class, so at the end of this lecture, you should be able to differentiate between what is the insulator, conductor, and semiconductor. And what are the difference between intrinsic. Intrinsic means pure, extrinsic means you are adding something inside the semiconductor. Why we need to do that? We'll go through one by one. And what is the difference between N-type and the P-type semiconductor. Okay, first, how are we going to differentiate the materials? Okay, the first one is insulator. What does it mean by insulator? Means there will be no current. Your I will be equal to 0. There will be no current flow inside the insulator. Means it is a very high resistance. Example of insulator is mica or rubber or any glass. Conductor. What does it mean by conductor? Anything that can conduct electron, right, can conduct current. Means there will be a current here. There is example is copper and aluminium. And the last one that will be the highlight for today's chapter is the semiconductor materials. So for semiconductor is between insulator, it is between conductor. So what does that mean? It can conduct and it also can be insulator. Sometimes it will have no current, sometimes it will have a current. So how we react on this semiconductor? We are going to increase the heat, apply the heat on the semiconductor, and you can have the current. So we'll see how this works inside one of the video. Okay, so let's see, this is one type of semiconductor. So we call this one silicon. So what will happen when you apply heat to the semiconductor? So as we mentioned before, it is semi. So sometimes it can be insulator, sometimes it can become conductor. So you apply heat at the semiconductor, so the LED will be turned on. So by applying heat, your semiconductor will become conductor, means it can conduct the current flow. By applying your semiconductor at room temperature, means no heat, it will become insulator. So that's how semiconductor works. Okay, so let's go back to the valence electron and the atom. What consists inside the atom is a nucleus which contains the positively charged. So we have nucleus in the middle here at the center, and you have a shell, and you have an orbit of electron. So the outermost electron at the outermost shell we call valence electron. So where is the valence electron? Here is from the outermost shell of the atoms. So this is what we call valence electron. How to relate that valence electron to the periodic table? So I believe you have seen this periodic table before inside your chemistry. So how we define the group? So we have how many group here? 1, 2, 3, 4, and the rest, right? So if the valence electron is equal to 4, what does that mean? Mean this one is group 4. So where is group 4? So this is where the group 4 is located. So the group 4 means here your valence electron, means the outermost the electron at the outermost shell is actually 4. So what is the example of the group 4? There is carbon, we have silicon, we have germanium. So all inside the group 4 we call semiconductor. The most material used for semiconductor is actually silicon. So where is silicon? Silicon is a group 4 because the valence, electron valence at the group 4 is 4 electron. Now, so let's move to the two types of semiconductor. The first one we call intrinsic. The second one is called extrinsic. What does mean by intrinsic here? It's intrinsic. It is a pure form. Means it will not be mixed with other material. It's only semiconductor from the group 4. So, intrinsic semiconductor is a pure form of semiconductor. The example of the semiconductor is silicon. So, as we know before, silicon has 4 valence electron. Means here the outermost electron at the outermost shell is for 1, 2, 3, and 4. So, when there are 4 valence electron, it will be shared in between the other atoms. So this is what we call covalent bond. So its covalent bond is very strong, so it shares the electron between 2 atoms. So what is the example of intrinsic semiconductor? We have from the group 4, we have silicon and germanium. We call this one elemental semiconductor. So the density of electron and holes for intrinsic semiconductor, for example, silicon and germanium, are equal. So this is a pure form of semiconductor. Okay, let's see some animation here. So silicon, how many valence electron of the silicon? We have 4. So for example, here is 4 electron. So what will happen between these 2 electrons here? There will be a covalent bond sharing together the electron, where we call this one a covalent bond. So this is what we call sharing of electron. There is covalent bond. So at the intrinsic semiconductor, when we don't apply any heat, means the temperature is 0 K. So this is at room temperature. What is happening between this atom of the silicon? This is what we call covalent bond. So at 0 Kelvin or 0 temperature, the valence bond here is very strong. Means there will be no free electron. How the current can conduct? What is actually current? Current is the movement of free electron. So if we look at this configuration here, all is pure. This is intrinsic, right? Pure. All the electron here is sharing together by covalent bond. Covalent bond is very strong. So we cannot see any free electron movement inside the pure semiconductor at T equal to 0 K. So when there is no free electron, means what will happen to the current? There will be no current at the pure semiconductor at T equal to 0 Kelvin. So means in this part where at T equals 0, the semiconductor behave like insulator, because there is no free electron. Why there is no free electron? Because there is a covalent bond here, and this covalent bond is very strong, and no free electron exists inside the pure semiconductor at T equal to 0 K. Means no heating applied at the semiconductor. Okay, now let's see what will happen. It's still pure intrinsic, but we're going to heat the semiconductor at T equal to more than 0 K. Let's say 40 or 50 degree. So what will happen at the covalent bond? So we know in between here there is a covalent bond. But once you apply heat at the semiconductor, the covalent bond, the valence electron at the semiconductor start to gain what? What we call thermal energy. So this thermal energy is required to break the covalent bond. So what does that mean here? When you apply heat here, when there is a heat at the silicon here, your covalent bond will be broken. Why? Because you are going to gain thermal energy by heat the silicon. So it will going to be break. So when it is broken, there will be a free electron exists inside the semiconductor. Once there is a free electron, there will be a current. So when your pure semiconductor is heated more than 0 Kelvin, it will break the covalent bond. First, it will break the covalent bond. So when it break the covalent bond, you will have a free electron and then you have a current. So what does that mean here? When you heat your semiconductor, the pure semiconductor, it will become conductor. Means it will have a current flow. But the current flow here is very small. So why are we saying very small? Because it is difficult to break the covalent bond. You need to apply a very high heat here. So it will create only a small current. Okay, so let's see some illustration here. So this is a pure semiconductor. We have silicon, and exists here is a covalent bond. So once you are gaining thermal energy when you apply a heat, T equal more than 0 Kelvin. So you can see at the slide here where it start to move up. Means that it start to break the covalent bond and it become a free electron. So once it become free electron, here will become empty and you're going to start to, the electron start to move here, right? Your free electron start to move from one to another. So there will be hole here and it start to move again, and that's where the current will flow. Okay? So as a summary here, when your semiconductor is at room temperature, means T equal to 0 K, it will become insulator. When you start to apply heat at more than 0 Kelvin, it will become conductor. Why it become conductor? Because your thermal energy will break this covalent bond. But is it difficult to break the covalent bond? Yes, that's why it will create a very small current. Okay, so that's all for this video. We'll see how the band gap energy works inside the conductor and inside the semiconductor. Thank you, class.